All right, good morning, you awesome Altaloma High School honors kids. Hope everybody's doing all right out there. This is a pretty brief video because I just want to highlight the difference between these two things. This is what we did yesterday, the thrown object model, where we had h of t, the height at a given time, or the time at a given height. You can look at that both ways. The -16, that's due to gravity. Time is t, which is always in seconds. The v is the initial velocity. Remember, if the initial velocity is away from the Earth, it's positive. If it's going towards the Earth, it's negative. And then you have s, which is the initial height. But the question, number 18, in fact, yesterday, came up where there was no initial velocity because I think it was a worker dropped a pair of gloves. Well, that leads us to something called the falling object model, because if you think about it, if you drop something, there is no initial velocity. You're holding something in your hand and you let it go. The initial velocity right at that point is 0, just like number 18 yesterday. So if this is 0, this is what it leads us to. You get this h of t equals -16 t squared plus v sub t like this plus s. But what happens if I said v sub t, I didn't mean that, v sub naught or v naught. What if this is 0 like that? Well, if this is 0, well, then this just disappears. 0 times t is 0. So the falling object model becomes this, -16 t squared. This is 0 plus s. So in other words, all we're dealing with is time, the height at a given time, and the initial height. We've actually done problems like this already this year. Let me show you an example. And the nice thing about this, by the way, is when you're dealing with the falling object model, as far as choosing a method, since there's no t there, we can just take square roots. So this is a pretty easy type of problem to solve. Let me show you an example. Okay, here's an example. We've done problems like this before. A monkey drops a banana from 50 feet up in a tree. This is the initial height. How long is the banana falling? Well, the banana only falls until it hits the ground, and on the ground, the height is 0. So this is the falling object model, and it's a falling object model because the banana is dropped. It's not thrown at the ground. It's not thrown in the air. It is dropped, which means its initial velocity in the monkey's hand would be 0. So we're going to use this. Another thing that's going to be 0 is this height right here, because we're asking how long is it falling. Well, it falls until it hits the ground, and that's at 0. This is going to be -16 t squared, and then this initial height is 50. We've done problems like this before where like the monkey dropped the banana and then it landed on a 10-foot tall bush, you know, and then you'd put a 10 right here instead of 0. So we've done that before, and these become very easy, as I said, to solve, because as far as choosing your method, since it doesn't have a t, it's real simple to just take some square roots like this. I would divide by -16, divide by -16, and what do I get? I get 50 divided by 16. Here's what I get. I get 3.125, and that equals t squared. And then I just take a square root like that. And when I take the square root of 3.125, I get t is approximately 1.8 seconds. So that banana would be falling for nearly 2 seconds, about 1.8 seconds. I'm sorry if that went off the video a little bit, but here's what I did. Subtracted 50 divided by 16. That got me 3.125, took the square root. Really nice and easy. Make sure you do this step, by the way, right here, dividing. If you tried to take the square root right here, you'd end up with an imaginary square root, and here too, and that really becomes messy. So make sure you're isolating this t squared. All right, that's the falling object model, all right? You guys got questions, hit me up with a remind text, okay? Hope you guys are doing well. Miss you all. We'll talk soon.